Hey everyone, welcome back. Today we're doing day 15 linked list in C++. Linked list is a new data structure that we'll be exploring. And in summary, linked lists are typically used to store a linear collection of items. And what it consists of is that it consists of nodes, where these nodes are objects containing two instance variables. The first instance variable is the data itself, and in this case, for this question, the type of the data is of type integer, as defined on line 7. The second instance variable is next, which is a pointer to the next node in line. The difference between a linked list and a list is that memory is stored contiguously in a vector or in an array. But in the case for a linked list, that is not the case. The memory that is assigned to every single node in the linked list is not necessarily contiguous, but it works because every single node has a pointer to the next node in line. So it still works as well. So a typical use case of a linked list is, for example, implementing a queue where it supports pop left as well as append. So we could do that with a vanilla list, but the thing is, if you try to pop the first element inside the list, which is pop left, then you would need to shift all elements inside the list one index to the front. So that can be very expensive in terms of time complexity. So to be specific, it's linear time. Because if you have 100 elements and you pop off one element, then you have to shift 99 elements forward. But if we use a linked list, then popping off a node inside the linked list is as simple as just setting the second node as the new head of the linked list and deleting the first node. So that is constant time. So linked list is pretty useful in many cases. And for this question, we'll be exploring how we can use a linked list. So in this case, a node class was given to us from line 4 to line 13. And in this case, as we discussed, the node object has an integer data field. Is pretty much a variable that contains the data that we want, as well as a pointer on line 8 that points to the next node. So for this question, the insert function is also given to us here. And it has two parameters, a pointer to the head of the linked list, as well as an integer data, which we want to insert into the linked list. And this insert function will return back a pointer, which will point to the head of this linked list. So in this case, our task is to complete this insert function so that it creates a new node, pass data as the node constructor argument, and insert it at the tail of the linked list. And once the new node is added, return the reference to the head. In this case, as usual, HackerRank is really nice to take care of the input and output for us. So you can see that they even implemented a display function to display all elements inside the linked list. So they read in T. T represents the number of items inside the linked list. And for each of these elements that follow afterwards on every line, these items are inserted into the linked list. And afterwards, the contents of the linked list is displayed on line 43. So our job in this case is to implement this insert function, and that's pretty much it. So with that, let's get started. So the first thing that we can do before we do anything is to check whether if the head is pointing to null. In other words, like it contains nothing. So if head happens to be null, then in this case, then we can just return back a new pointer to a node. And what we can do on line 19 before this check is to define a new pointer to a new fresh node. So to do that, we can define a node pointer like this. Let's call this new node, and let's define it as this. And because we want to allocate memory on the heap to assign this to a new object, and we want to call the constructor as well. What we do is on line 19, we use the new keyword operator to assign memory to this node object, as well as return back a pointer to this variable over here. And once done, if head is equals to null, then all we have to do is return this pointer as the new head of this linked list. Else, in this case, if this means that the linked list is not empty, then what we have to do is to define a current pointer and assign that to the head of the linked list. and iterate this all the way to the final node of this linked list. And once we are done, we can set the next property, the next attribute of this final node to point at this new node that we created. So to do that, we can define a node, and let's call this current pointer, and we can set this to be equals to the head. And once we're done, while current next is not equals to now, in other words, the next pointer is not now, then we can advance the current pointer to point at the next node in line. So current pointer is equals to current pointer equals to current pointer next. And in this case, what we are doing is that we are just advancing the current pointer as long as the next attribute is not equals to now. So you just keep advancing the current pointer to the end of the linked list. And by line 28 in this case, then we are guaranteed that current pointer is pointing at the final node inside this linked list. And what we can do is just assign current pointer next to be equals to this new node that we just created over here. And once we're done, we are complete, and all we have to do is return the initial head that we received. So we just pass this head that we read in over here, and with that, we're done with our implementation for inserting a node to the linked list. Let's run this code to test it against the test cases. This passes the test cases, and let's submit this, and we're done. So in summary, we learned how we can implement the insert function to insert a linked list node into a linked list. And we also learned how we can iterate a current pointer to the end of the linked list before we assign the next attribute of this final node to another fresh node. So with that, that's pretty much the end of this video. If you find this useful, please give us a like and subscribe, and we will see you in the next video.